Welcome to my channel. Your tutor Mariam is here. It's a 22nd video of Introductory Physics 1, and the third video I'm going to talk about the motion in 2 and 3 dimensions. That is the fourth subject of Introductory Physics 1. In this video I'm going to talk about the acceleration and velocity in 1, 2 and 3 dimensions. So this chapter is like a combination of chapter 2 and 3. In chapter 2 you guys learn what is the equation of motions, and in chapter 3 you learn how to write down the vectors and what is the unit vectors. In this chapter is like you're gonna write down the equation of motion in terms of the vectors, and also you learn what is the projectile motions. So if you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and look for more. You ready? Let's get started. Let me talk about the position, velocity, and acceleration in one dimension first, that we all know about that. So displacement is like a final position minus the initial position, right? And then the velocity gonna be the displacement divided by the time interval, and then acceleration gonna be the derivative of velocity divided by the time interval, right? So this is like I have a car, and then I only have one dimension as an x-axis. I'm gonna move the car only in one axis, right? So the displacement gonna be the distance that a car drives. So it's gonna be a delta x. And then if I take a derivative and divide it by time, it's gonna be my velocity. And then if I take a derivative of velocity based on time, it's gonna be the acceleration, right? But what about 3 dimensions? 3 dimension is also the same idea, but at this time we are dealing with 3 coordinates like x, y, and z axis, and these coordinates are perpendicular to each other. Let me go back to the example of that car. So I have this car, and now I have 3 axes, x and y and z, and these are perpendicular to each other, right? So if I move the car to this location, so that means my car move in 3 axes. But the way I can consider it is like each axis have the independent direction from the other one. What I mean by that is like in the x coordinate I can write down the displacement in x. In y coordinate, I can write down the displacement in y axis, and in z axis, I can write down the displacement. And what I mean by that is like this r can be as x2 minus x1 in I direction or x direction, and then is gonna be y2 minus v1 in j direction, and then for z I'm gonna have z2 minus z1 in z direction, right? So that means I cannot add or subtract x2 and y2 because they have a different coordinate, and x, y, and z axes are perpendicular to each other. So if I write down x2 minus y2, this is totally wrong because they have a different direction. You can say x2i minus y2j, something like that. But you cannot say x2 minus y2 and given no unit vectors. Now let's look at the example. Here I have a position as a function of time in x and y axis, like in 2 coordinates. And then I need to find the velocity, magnitude, and angle of the velocity. I also need to find the acceleration and magnitude and angle of acceleration. Let's solve the first part together. So in order to find the velocity, I need to take the derivative of displacement, right? So velocity gonna be dr over dt. Why I'm writing down dr? Because I have two coordinates, x and y. So then this guy gonna be dx dt, right, in I plus dy over dt j. And remember, it's gonna be add together, not subtract. And now I'm gonna take the derivative from x, this part right here. So it's gonna be d dt 3t squared plus 1 in I plus d dt 4t plus 2t in j, and that is equal to 6t in I plus 12t2 plus 2 in j. Now I'm gonna substitute time as t equal to 2. So my v gonna be 6 times 2 in x-axis plus 12 times 2 squared plus 2 in y direction. So it's gonna be equal to 12i plus 50j. Now I need to find the magnitude and angle of velocity. Let me write down what we have so far. So I have 12i plus 50j. This is my v, right? And then my magnitude for v gonna be vx squared plus vy squared. Then it's gonna be 12 squared plus 50 squared. Then it's gonna be 144 plus 2500. That is equal to 2644, and it's gonna be 51.4. And then for the angle theta, I have tan minus y over x. So it's gonna be like in the y direction divided in x direction. So it's gonna be tan 1, and then 50 divided by 12 equal to tan minus 4.1, and it's equal to 76.2, and it's in degree. So if you calculate it and you end up with a different angle, make sure you calculate it in degree, not in radians. Now let's look at the part C. So here I need to find the acceleration. Acceleration is a derivative of velocity, right? And we already found the velocity from the previous part. Velocity was 6t in I plus 12t2 plus 2 in j, right? So if I take a derivative of this guy, then I can write down the acceleration. So my acceleration A gonna be dv over dt. So it's gonna be 6i plus 24t in j, right? Now I need to substitute t equal to 2 here. So the point is here in x-axis nothing's gonna change because it's not dependent on time. So it's like in x-axis my acceleration is always constant and it's time independent. However, in y-axis it does depend on time and I need to substitute time here. So then my acceleration is gonna be constant plus 6i in x direction, and then for the y direction is gonna change with time, so it's time dependent, and it's gonna be j, right? So I have 6i plus 40aj. Now let's find the magnitude and angle. So for acceleration here, I have 6i plus 48j. This is what I just got. And then for the magnitude is gonna be ax plus ay squared, right? So then it's gonna be 6 square 48 square. Then it's gonna be equal to 36 plus 23 4 equal to 2340 equal to 48.3. And then my angle theta gonna be tan minus is gonna be ay over ax. So it's gonna be equal to 48 divided by 6. It's gonna be tan minus 1, 8. And then it's gonna be 82, and again it's gonna be in degree. I hope this video helped you to understand these subjects better. If you like my video, the subscribe button, and see you in the next video.